right, since we had issues with Google Meets, we're going to go through the pedigree chart. You can follow along as you watch through the video and pause it where you need to. And then remember, if you ever have any questions, feel free to email me. So when we're talking about pedigree charts, what does that mean? Well, we're not talking about the dog food. We're actually talking about this chart here that you can see on the right. So a pedigree is a diagram that traces one trait through several generations of a family. Now, it's important that we understand that it's just one trait that we're tracing. So it could be blood type, it could be hair color, eye color, any of those traits that we've talked about when focusing on genetics. Now, on the pedigree chart, you'll see two shapes. All right, the circles represent female and the squares represent male. So if we were to look at this simplified example here, we've got 1, 2, 3 circles. So that would mean that there are 3 girls, and then we've got 2 squares, which means there are 2 boys. Now, when you're looking at the pedigree chart, at the top you'll have mom and dad, and then the first circle on the left would be the oldest daughter, the second daughter, and then a son. And we'll talk about what these horizontal and vertical lines represent. So one thing to make sure that we understand is when you're looking at the offspring or the children of mom and dad, you always will have the oldest on the left, youngest on the right. All right, almost like when you're reading a book, okay, from left to right. So oldest on the left, middle child, and then youngest on the right. So daughter 1, daughter 2, and then the youngest son. So what do the horizontal lines connecting represent? Well, they represent marriage. All right, so anytime you have two shapes, so a circle and a square, a mom and a dad, and a line that connects them that's horizontal, that represents marriage. So if you're looking at this example 2, all right, you're going to look for how many horizontal lines you can find. All right, there's one horizontal line in between A and B, a horizontal line between E and F. So we would say that there are 2 crosses or marriages in this pedigree chart. One thing to make sure that we don't include this as a horizontal line. Okay, this comes from both mom and dad. This is just the offspring. So a vertical line extending down from a marriage or a cross represents that the couple has had children. So you've got the mom and the dad with the horizontal cross showing marriage, and then the vertical line down, that represents that that couple has had children. So if you're looking at this example here, we would say that A and B married and had, if you look at the vertical line down, 3 children. And then if you look at E, this is their youngest son, he also married F, and they had a child. And that child would be a male. So how many couples in this example have had children? Well, here's a couple here, the horizontal line, and then they have a vertical line, so this is their children, so that would be 1. Here's another couple with a horizontal line, so that would be 2. Here's a couple with the horizontal line. Notice the vertical line down represents that they also had children, so there's 3. And then N and O here, all right, we've got the horizontal line with the vertical line down representing that they had 5 children here. So there should have been 4. 1, 2, 3, and 4. Now, you're probably asking yourself what this is. Well, we're going to look at that on the next slide. So, if for whatever reason within a pedigree chart, if you have twins, this is how it will be represented. So you've got the couple here with the cross and the vertical line down, oldest daughter, middle child, daughter, and then 2 twin boys. That would be the youngest. Now, to trace a trait as you go through the pedigree chart, you're going to have boxes that are shaded all the way in, half shaded, or left blank. So if your box is shaded, that means that you carry or have the recessive trait. Now, if your box is left blank, that means that you are homozygous dominant. If your box is half shaded, that means that you are heterozygous, so you carry both the dominant and the recessive. If your box is shaded all the way in, that means that you are homozygous recessive. And then if you have a box with a line through it, a diagonal line through it, that shows a mutation. And remember that a pedigree chart only follows one trait. So if we're looking at the trait for rolling your tongue or not being able to roll your tongue, you'll see that mom, which is represented by a circle, is half shaded, which means that she's heterozygous. So she has one capital R, one lowercase r. Dad, who is left completely blank, would be homozygous dominant, so would have both of the dominant alleles. So then if you look at their offspring, the first and oldest daughter is heterozygous. Then you have the middle daughter. She is homozygous dominant. And then the son is also heterozygous. Now you can look at the probability of having these traits by plugging these into a Punnett square. So you can see here you've got the dad, which is homozygous dominant, and then the mom, who's heterozygous. And then if you place those into your pedigree chart, you can see that there's a 50-50 chance that the offspring is either going to be homozygous dominant or heterozygous. So let's look at some practice questions. All right, so what is wrong with this pedigree chart? Go ahead and pause the video and see if you can figure that out. So what's wrong with this pedigree chart is that the offspring right here cannot be homozygous recessive, right? Because the dad is homozygous dominant, which means that he's going to hand down one dominant allele, which would mean that this would be impossible. Same thing can be said for the youngest daughter on this pedigree chart. And then if you're looking at the offspring in the third generation, you've got a homozygous dominant and a heterozygous. So it would be impossible for that son, that offspring, to be homozygous dominant because the mother is definitely going to hand down that recessive allele. So you can also look at a pedigree chart and determine what the possible phenotypes would be. So if you look at mom, she is heterozygous, meaning she has one capital or one dominant allele and one recessive. And then if you look at the father, he is also heterozygous, meaning he has one dominant and one recessive allele. So you could plug that into your Punnett square. And you can see that there is a 25% chance that they are homozygous dominant, a 50% chance that they are heterozygous, and a 25% chance that the offspring is homozygous recessive. So we could actually say that W could be, well, either of the three. More than likely, the 50% chance is, heterozygous, but they could still be homozygous dominant or homozygous recessive. So pedigree charts help to trace genetic diseases, and most genetic diseases are a recessive gene. All right, so that's why we always focus on the recessive trait. So if you have one recessive, you are a carrier, but you are not sick. So that dominant allele is always going to mask the recessive. So you're a carrier, but you're not actually sick. If you have two recessive genes, you are sick with the disease. So we would say that you're affected. All right, so let's look at these questions here. What I'd like you to do is pause the video, go through, try to solve them, and then play the video once you have them filled out, and we'll check your answers. So question 1, how many children do the first generation have? The answer is 4. So if you look here at the first generation, you can see the cross here showing marriage, and then the vertical line. You can see that they had 1, 2, 3, 4 children. How many girls did the first generation have? 3. 1, 2, 3 circles. Those represent the children. This would not count because what happened was this female married one of the first generation's sons. Describe individual Y. So if we look at individual Y, we would say that Y is a granddaughter because you've got grandparents, parents, grandchildren. In the third generation, the oldest sibling out of the two. And then you could also say that she's a female and a carrier. If we're looking at individual Z, right, Z is a male, middle child, third generation, and is also a carrier of the disease. How many children and grandchildren have the disease? One. So if you look at how many children and grandchildren have the disease, first you're going to look for the boxes that are circled in, so the ones that are affected, and you would only have one here. Okay, remember this one doesn't count because this individual, this female, married into the family. What is the genotype of X? The genotype of X would be 2 recessive alleles, so homozygous recessive, and then you can see that since it's shaded in, they're affected. That means that they have both recessive traits. What is the genotype of Y? If you look at Y, we're half shaded in, so that means they're a carrier, which means that they're heterozygous and they have 1 dominant, 1 recessive allele. How many children and grandchildren are carriers of the disease? So you would go through and look for all the half shaded boxes. So you've got 1, or half shaded shapes, so circles or squares. 1, 2, 3, 4, 5, 6, and 7. So 7 of the children or grandchildren are carriers of the disease. All right, so what is a carrier? All right, remember, a carrier is a person that carries 1 copy of the disease gene, but it's masked by the dominant. Okay, so it doesn't show up as a phenotype, but they are the carrier. They have that ability to hand down that trait to their offspring. How many kids did W and his wife have? Here's W, here's his wife, here's the vertical line, and you can see that there are 2 children. Who is older, U or V? Well, here's U, here's V. Remember, left to right is oldest to youngest. So our answer would be U. And then how do we know? U is further to the left. This makes U older than V. All right, so that is the PowerPoint for today. If you have any questions, please feel free to reach out. And I recommend using this PowerPoint, which I'll upload it as a PowerPoint, but also this video to help you better understand pedigrees, and it'll definitely help you as we work through pedigree charts this week. All right, thank you.